Hello, my mud fossil friends. You're going to be blown away. That is grip skin from giant fingertips. It's the skin of the tips of your fingers and your toes and so forth. Now, look at what you got here. These are Yooperlites. Now, they just got discovered a couple of years ago, 2017. Now, watch what's going to happen here. You see this one here? What you saw up, well, can you see? Yeah. What you saw up above was this same sort of fabric. Now you're going to see something different though. You're going to see it in ultraviolet light. Now watch.
These magical glowing rocks are called Yooperlites and are found on Lake Superior beaches in Michigan's Upper Peninsula. Now what makes these rocks so special is they were only discovered in
See that? That's the same type of, well, you see it right there. And you see it right there. All right, now that's the same type of fabric. Now, that's what shakes me up a little bit on this, because originally I thought these were specialty particles which were in the lungs or in the blood of a creature. But this looks to me like it's a grip skin, but I don't know. It could just be fashion. So anyway, here we go. Let's keep going.
2017.
Let me go back to make sure we get a good shot at this here. Here we go. So now you've seen the fascia. It's going to be coming up.
Special
or the grip
is
skin.
they were only discovered in 2017.
Ooh, wait. You know what? It doesn't have the same amount of particles. I missed that. You see how this one here glows like crazy? Glow, 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 glow. That one's not going to glow, but you're going to see a couple particles. That I can understand now.
Only discovered in 2017.
You see, it's got one here, it's got one here. They're in part of these fibers. Okay, now I got something I can look at. They are incorporated in part of the fibers. Very, very, very interesting, and I might say illuminating. All right, here we go.
German mineral dealer Eric Mataki is an avid rock hunter who beachcombs all year round, even when the temperature drops below zero. His favourite rocks are agates, which are getting harder and harder to find on Lake Superior, so he wanted to see if he could find a better way to spot them. He saw an ad on eBay showing how agates light up under UV light, so he decided to try and look for them with a UV flashlight at night. Eric said, "The first 3 times I went out, I found nothing, but on the 4th time, I was on my hands and knees at 4 AM and I found a rock glowing with bright fluorescent orange, and I screamed with joy." The glowing rocks that Eric stumbled across were emitting a potent yellow and orange glow when exposed to ultraviolet light that gave the appearance of being partially molten.
All right, yellow and orange are a certain frequency that are sort of long frequencies compared to, white light. They're in the red shifted zone. Red goes further out, but you go from orange and yellow and then green and blue and so forth like that. Shorter and shorter frequencies. And I draw it up. I got this little Wile E. Coyote diagram showing why these things happen and how actually the nucleus is made and how these actual light. Okay, my friends, Roger, Mud Fossil University and National Geographic now is looking into mud fossils. They call it permineralization, which is, I agree with that. And what happens is they turn into things like that. That's a bone, but it's been permineralized. And I'm explaining to you, and this is an apical tuft, and that's been permineralized. And I have other things. That right there is a human lung, and that's been permineralized, and that has been DNA certified. So it's not a question whether it's a human lung or not. It is, and it has been permineralized. So let's see what they have to say, and then I'm going to make some statements about their conclusions and my conclusions. So here's National Geographic addressing mud fossils, quite obviously saying Fossils 101, National Geographic. Now I'm just going to cut to the chase. They're talking about soft tissue fossils. Here we go.
Trapped organism. Over time, the soft resin hardens and turns into amber, with the organism suspended within. This process creates a biologically inert tomb for the organism, allowing its soft tissues to be remarkably preserved.
All right, that is fine. That's good. Guess what else does that? Salt water, fine anaerobic polar molecules of mud. All right? The salt conditions in there are preservatives for flesh. Everybody knows that. Anybody that's ever worked with preserving anything understands that. So the salt is primarily the preservative. The fine polar particles plate the creature. They literally plate these things. They literally get plated with electricity. And why do they do that? Because they're in the mud, they're in the water. The earth has telluric currents that pull electricity down into the earth. 100% guaranteed. What's in the middle of this? What's in the middle of that chemistry? What's in the middle of the chemistry? Molecules. What's in the middle of molecules? Negative particles that attach and detach. And of course the positive particles are part of the nucleus. Now, this is what happens, and then they get preserved. That's in amber, and that's wonderful. I like that. That's great. But it also happens in the mud fossils, and my mud fossils get preserved in as good as that or better. Let me show you something Gary Evans found. All right, this is Gary Evans found this, and I hope he's all right. This goes back a couple of years. I haven't heard from him in a while. Gary, I hope you're all right, brother. Comment on this. All right. He saw my same as everybody else. I saw what you had. I went out, I looked, and boom, I saw this rock, and I thought it was unusual. It had those little bumps on there. So he banged it open, and here's what was inside. And he said, I looked at that, and I thought that was kind of interesting. And I said, yeah, you just opened up a lung. And that's a pretty obvious lung. Anyway, I know it's obvious because I understand the lung. That's the red part of the lung where the arterial blood comes down. This is the vein blood. It's black blood, and it transfers the molecules. It's called carboxylation. Carbonic acids turn into carbonic gases. They go blow out through your lungs. There's 3,500 of them that comes out of your lungs at least. And these are all transferred from transition metals, and that we're going to get into too because that is fascinating. And Greg Morrison sent me something on that. And I'm telling you right now, I have to give credit to all these people. Because here, I'm going to show you something. Right up there, I'm just going to say right now, I'm looking at these Yooperlites. And they're in this. You can't see it. We're going to go over in a second. And Greg sent me that. Gary Evans sent me this. I just got off the phone with Phil Harris, who is, I call him Phil the Heartbreaker. He went out 15 minutes, same thing, went out, found a heart broken in half, and it is absolutely stunning. The blood just leaked all over, and you can see the same thing, the red, the black, and the yellow, and that's what happens. You get a yellowy looking thing between the red and the black, and it happens here. See that? That's a lung right there. That's a lung. And I actually had a doctor call me and say, I can tell you how that guy died, which way he was laying, because the blood has drained down, obviously. So I said, oh, that's nice. Anyway, I mean, it's just what it is. It is what it is. So now what happens to this lung? So Gary, and here's why. I'm going to teach you what happens to mud fossils and how you have to keep them protected. You have to dry them out in a certain way if you want to keep them. And when they come right out of a wet mud flat, that's a whole different kettle of fishies. All right, then they show this as forms of fossilization. They call it carbonized leaves. Well, they're not carbonized. They are, that is, well, they might be on plants. Yeah, I guess on plants they would be. On this, it's more iron from the bone. That's the distal phalanges bone. And this is what the apical tuft would be at the tip. See if I get some light over here if it makes any better sense. And that's where the vein and the artery is. Veins clamp off, arteries blow out. Okay. So now, and then this is a bone. The bones don't preserve. This is what happens to bones. Right? The bones transition. Now, sometimes they'll completely dissolve. But if they don't, they transition. You're never going to find a white, regular-looking bone. But that's absolutely a bone. But it's so well articulated because all of the coating is preserved because that's fascia. This is all soft tissue. It even wraps itself. Look at this. See that? I don't know if you can see that. Let me come on this way. Hold on, I'm moving it. Here we go. Take it easy. Don't hurt yourself. Here we go. Now, if you could see, which I can't see, but maybe you can. There we go, there we go, there we go. You see that? See that triangle looking thing? Like a crescent roll right on me. I see my wife making these things, you know, they got a little flap that folds over and they weld it there. I don't know what to tell you, but that is what it is. And that's called tunica. I've seen it in the microscope a million times. As a matter of fact, it's right up here. All right, it's in this stuff. See this? Oops, I got the wrong mouse. Too many mouses spoil the tea. All right, you see this? This is the kind of stuff we're talking about when we're dealing with, you know, biological stuff. And Tyson says he's finding things like that black stuff right there, big chunks of that stuff out on his membrane. You see this thing, absolutely stunning. That is the grip skin pattern, and that pattern is in this as well. You see, because this is grip skin too, because the figure. I tell you, my eyes are as bad as eyes can get and still be able to keep going. All right, there it is right there. You see that? I think you can see that. You see that pattern there? That's so your fingers don't get torn to shreds when you grip things and you pull real hard on stuff. It'll rip your skin right open. Try to do that, rip the way you can rip things with your grip skin because of that strapping. Try to do that with your eyelids. I can't help it. This, I find this hysterical. And this is the blood. And everybody thinks the blood is, oh, that's the weak stuff. No, no, it's just the opposite. The blood is what does something called chelation. That's a fingertip. And chelation means that the blood itself gets wrapped with these little molecules that surround it, and because it's a metal complex. And blood, I don't think it ever goes bad. I don't know, maybe it never does. Honestly, it must go bad at some point. They say, oh, you can't get blood out of a rock. Can't get a rock without a blood. And up here, look, well, now I'm going to start bragging. It just comes with the territory. All right, so we got that. Look at this. Here, you want to see some stuff? Look at that thing. No, you telling me that's not biological? This is the black blood, there's the red blood, there's gold in here, there's all the transition metals. And that's what I'm doing is the transition metals. And I got so much freaking stuff, it's just absolutely amazing. And, you know, I think I got a lot of some really interesting stuff, but everybody does. You walk out, you know, because everybody I said to them, go look outside. Not a one has been unable to find something. These are all veins, bone foramens. There's bone foramen, vein and artery going down inside the bone foramens, down over. See the black and all that stuff? That's blood. That's bodily fluids, my friend. You see that? If you can't see bodily fluids there, I don't know. You better, you know. I hope you're not a brain surgeon. And that's blood turns black when it comes out because that's the deoxygenated. That is a vein. That's a vein or an artery. I forget what I came up with. No, I think it's an artery, and that's blood cells and things leaking out. And I mean, it's just, I don't know what else to say other than to say what I say because I say what I say. And that's a lung right there. Now, I'm looking at these lungs and I'm thinking, oh, lungs don't have any of this Yooperlite because I can see it. But then I realized from the video Tyson did yesterday that what I'm going to be looking for, I need a microscope.